Hello. Let's see how we could use Mono.Cecil to instrument our .NET binary. And in this video, I will show you how you can inject some simple stopwatch code that will calculate how much time execution of the method takes, and it will print on the screen what's the time of the execution of the method. It will be a bit harder example than the previous one when we just printed entry and exit of the method, but nonetheless it won't be that hard. So I'm starting with this program CS, which is just simple, let's call it starting place. So I'm already have Mono.Cecil imported, and we read the file name from the arguments with this module definition read module, and we do this trick to make sure that whatever we print on the console gets printed. And then there are two for each loops, first one going through all the types in the module, and then for each type we go through all the methods, and then if the method doesn't have a body, we'll skip it. Otherwise we'll take this yield processor and we will work with it. So maybe to get started, let's just write what the code would look like in C#. So we would have something like var new stopwatch. Then we would call start on the stopwatch. Then we would have original code. Then after that we want to stop the stopwatch, and at the very end we want to console write line, and what we will write would be method name took and we will call here elapsed, and that's all. So this is the code that we want to have. So let's get started. So the first line, it's consisted of two things. So first is this new stopwatch, and then assigning to some local variable. So let's just write that. So first we need to call the constructor. So in order to call the constructor or to construct an object, we need to have the constructor method. But first, okay, so this will be a new object opcode. That would be il processor create opcodes new object, and then we'll pass the stopwatch ctor, so the stopwatch constructor. So we need to have this stopwatch constructor. So let's just write that, and we will get that by importing a reference, and we will just go type of stopwatch, and we will get constructor. And so what would be the constructor? Binding flags would be instance, okay, and it would be public constructor. Then the binder, we don't care. Now the types. So our constructor doesn't take any parameters, so it will be an empty array, and parameter modifier also we don't need to pass. So that would be our constructor. So we'll get a reference to this constructor here. This would be a method reference, and we will pass it to the new object opcode. Okay, and then the new object will be created on a stack, so we will have to store it in a local variable. So we need a store loc opcode. It will be il processor create opcodes store loc stl loc, and then we need variable declaration, let's call it like that. Okay, and to have this variable declaration, let's just declare it. So we need new variable, it's called definition here. And here we need a type reference. And this variable has to be of type stopwatch. So stopwatch ref. So we need this reference. So let's just also get it here. So var stopwatch ref. And we'll use the same module import reference. But here we'll use this type and we'll get type reference. Right? We wanted to have type reference here. So we can just use type of stopwatch and we'll get this reference, type reference. Okay, so we have those two opcodes. So first we'll get create a new object using the stopwatch constructor, and then we'll store it in this variable definition. Oh, there's one more thing. We need to add this variables. We need to add to the collection, so basically it is known that it is a local variable of this method. Okay, so now we just created those opcodes, so we need to inject them to our body. So again, as in the previous example, we'll just get first instruction. We'll use methods, body, instructions. First we'll use linku to obtain the first instruction, and then we can use this again il processor insert before. We get the before will be the first instruction, and we'll use this new opcode, and again il processor insert before first instruction and store lock opcode. Okay, maybe I will just correct this name. It should be st lock store location, and also here. Okay, so that gives us the first line. So now we need this one. So in order to do that, we need to do two things. First, we need to have the object, the stopwatch object on a stack, and then we'll need to call the start method on this object. So first would be ld location opcode. So it could be probably optimized. We could just duplicate the object on the stack before we just store it, but I guess this would be more explicit. So opcode, we need opcode ld lock, and we pass the same variable declaration here. So we have the opcode, and then we will use it also. Insert before first instruction ld lock opcode. So now we have the opcode, and then we need to call the start method, so to start the counter. So we need call start opcode, and this will be el processor again used, create opcode would be call, and now we need stopwatch start reference. So we need this reference, and we don't have it. So again, we will just use module import reference. So we need stopwatch start reference, and on module we'll use import reference. We will use type of stopwatch, and then we'll get method that is called start, and we will pass what we can pass, that it doesn't take any types. Okay, and we have the stopwatch start reference, and then we will just insert it before our first instruction, call start opcode. Okay, and that's it when it comes to the first part. And now we will look into the ending part of this program. Okay, let's see how we could write the second part of our simple program. So again, we have 2 lines of C# here, but it will be a bit more IL code. The first one is fairly straightforward. We will use almost the same code as before. It will be just stop method instead of start. And the second one will be a bit trickier, but let's get started. So I will just write, even though we have this ld-log opcode here, I will write another one because I will use that a bit later. If I will reuse this one, I will have some issues. So ld-log opcode 2 il processor create opcode ld location and variable declaration. That's one, what we need. The second one would be call stop opcode. We'll just use our il processor opcodes call, we know that, stop watch stop reference, which we don't have, but we'll use the magic of import reference to get it. Module import reference type of stopwatch. That's nothing new. Get method. We'll just use method stop, and it also doesn't take any arguments, so just an empty array we pass. Okay, so we have those two that we need for this one. So now this one. So let's start with a string. So we need a string. So let's just use ldstr opcode, which you already know from the previous video. Opcodes ldstr, and we pass a string here. So we'll use the $sign here to get a method name value. Method name took, and here we use double curly brace, so it will not be analyzed by this $, and only by the console write line. So we have the ldstr opcode here. That would be enough. So now this part. So we'll use one of the ld-log to get the value on the stack. So now how to call elapsed, because this is property, and before we only called methods. But actually you already probably know that properties are just getters and setter, which are just normal method and functions. So we'll just call it as we would call a normal method. So call elapsed opcode, and again il processor create opcodes call, and here we will pass stop watch elapsed reference, and we don't have that reference. So again, magic of import reference, stopwatch elapsed, and here it will be a bit different. So we use import reference, we use type of stopwatch, and here we use get property instead of get method, and we pass elapsed, and then we use a dot, and we have those two get method and set method properties that allows us to get specific methods from the property. So we'll get that, and here it will complain that okay, it can be null, so we will get a null reference exception. So let's just use the question mark to, well, we'll get null if this is null, and probably import reference will fail anyway, but we don't get this underlying stuff, which yeah, is a bit annoying. So we get that. So we have this part, and we still need a console write line. So call write line opcode il processor create opcodes call and console write line reference, what we need, and we don't have it. And here it will be also a bit different from the previous video. If you haven't watched it, it's a bit simpler what we did there. We'll use type of console, and we'll call get method write line, but here we'll use different types for the argument that this method takes, because before we just used string, and here we'll use type of string for the first one for the format, and for the second one we'll pass an object. So that's the signature of console write line that takes two arguments, and we could see it either on some documentation on just like here and scrolling through all those methods somewhere here. Yeah, this is the one we'll be using. So string format object argument 0, and yeah, that's the one we want to have, and we declared that we want to import this reference. Okay, so we have this one, and we'll still need one more thing, because when you write such line in C#, something happens underneath. Because elapsed return time span, which is value type, and console write line expects an object, this will be boxed. So it will be converted to an object, actual like real object, instead of a value type, so reference type. And we also need to do it in our IL. So we need a box operation. So let's just do it. Box opcode, and we'll just use box opcode. It's that simple. It's really simple. And what box takes a type reference for the value type that it's being boxed. So in our case it will be time span. So we can pass time span ref. And we don't have it, but yeah, we'll use our magic of import reference. So time span reference module import reference, and we'll use this method now. So we just pass a type and we'll get a type reference. So type of time span, and we get a type reference. Okay, so I think we have all the constructions that we need for those two lines, and now we just need to use them. So we'll use a bit different construction than before and what we did here. So we'll not use insert before, because if we did that, we'll have some issues when we have some early returns in the method. Because early returns, even though you have a return in the method, underneath in IL, it's being coded as branch instruction to the last red, or to the red opcode, which is last in the method. So if we use like insert before, we'll insert our code before the return. So if there will be any branch instruction, it will skip those lines. And we don't want to do that. We want to have those lines printed even if there's like an early return in the method. So yeah, so what we do here, so we'll still get the reference of the last instruction, which we will in a moment use, and to get the last instruction we'll just use link. It's convenient. So what we'll do first, we'll replace the last instruction with first instruction of our new code. So it will be this ld lock opcode 2, ld lock opcode 2, and then we'll just add the rest of the instructions. So after we load, we will call stop. So we'll call stop opcode. So our stop is called. Now we will again, maybe not again. Now we will load the string on the stack. Add ldstr opcode. Now we will load again our object into the stack. And I will use this time different LD opcode. I will use this one because, as I said, I will use this one as a reference. So if I use in two places, the second place will be used, which will be confusing. So I'll use the first one to load the object on the stack. Then when we load, we need to call elapsed. So we'll add call elapsed opcode, and I can see already I make a mistake here because this is showed as not being used. I called start, which is not what we want. We want to call stop here. Okay, so let's get back. We have like we load, we call stop, we load the string, we load again the variable on the stack, we call elapsed, so we get this value. Now we need to box this value. Body instructions add box opcode, and at almost the very last opcode we want to call write line, and yeah, it's not over. So because we replaced the return with our LD location, we still need to add the return, because otherwise our function or method would be without return. So this is our new code, but it's still not finished because we changed this return and added some code. We will mess up all the branch instruction in our method. So we need to fix them. So we need to use for each in IL processor body instructions. We need to go through them and see if it's a branch instruction to a red opcode and then fix it. So let's first check if we are actually a branch instruction. So if the opcode is different than opcodes branch and body instruction opcode is different than branch short, then we'll just continue because we don't care about different opcodes. And now if our operand for our body instruction is something is not a return, we also don't care because that's not a branch to a return, so we just skip those. There might be some branches in the code, we don't care about them. Okay, and now in this body instruction operand, we just need to point it to our LD lock opcode 2, which is the first instruction of our new code. And yeah, if I would use the same LD opcode in here and here, it will point to this one. I don't know, maybe there's some bug or I don't understand how it should be used, but at least this works when I have different instructions. So we fixed those branch instructions here, so now our code should work. So let's just see if it does work. Okay, so let's call simple EL measurement XZ and we'll pass the same assembly. Okay, it did something. Let's just see if I run the modified version, it should execute something. In this case, since I'm not passing anything, it will do an early return and it should still print how much time it took to execute those few instructions. And yeah, it did print that the method main took 0 second, like some millisecond time. So yeah, that's all we did. Modified each method in the assembly to add a stopwatch and call a start method, and then at the very end call the stop method, elapsed, and print the information how much the execution of the method took. So yeah, that's all for today. I will put a link to the source code to for you to download, and yeah, I hope you liked the video. If so, please like and subscribe, and see you in the next one. Bye bye.